Okay, so we are looking at Electrician's Theory Exam, 23rd of June 2018. This one's quite a good one because it's closer to how the modern exams are structured. So, doing section 3, introduction. A nameplate of a three-phase, four-pole induction motor has the following information. Frequency 50 Hz, line voltage 400 volts, line current unknown, kilowatts 10, efficiency 81.5%, slip 4%, and the line current lags the voltage by phase angle 35. So we'll use it for this information for 14, 15, 16, 17. Question 14, calculate the power factor of the motor. So we've been given our phase angle, so power factor equals cos theta equals cos of 35, so cos 35, and we get 0.8191 rounding up to 92. So that is our power factor. Very simple question. Next one is calculate the input power of the motor. Now, we don't have a line current, so we can't use our power equals root 3 times I line times V line, but we do have our output power, which is 10 kilowatts. So what we do here is we go output over efficiency, which is 0.815 equals input. So our output is 10,000 over 0.815 equals 12270 once we round up watts. So we've got our power factor, we've got our watts. Next we have calculate the line current of our motor. Now we will use our three-phase power formula, but there we'll actually have to include power factor. So we have our current power 12270, or maybe I should write the formula first. P input equals root 3 times I line times V line times cos theta. So, rearranging that, we end up with PINP equals, and what we've got to do is divide both sides. So by our root 3 times V line times cos theta, doing the same on this side, replacing that. So P input over root 3 times V line times cos theta equals I line. I line equals, so our P input was our 12270, and that is over our root 3 times our V line, which was 400, times by our cos theta, which is our 0.8192. I line equals, grab our calculator, and we've already got that value in there, so divide by square root of 3 times 400 times 0.8192, and we end up with 21.62 amps. Next, we go on to question 17, calculate the slip speed of the motor. So, in S asynchronous, or RPM if you prefer, equals 60 times Hertz over POP. So in SY MC equals 60 times 50 over, this was a four-pole motor, so we've got two pairs, in sync equals 3000 divided by 2, so 1500. And then we've got calculate the slip speed of the motor. So this is the synchronous speed. We want to know how much it's going slower than that. And they told us we're slipping by 4%. So we just get our end synchronous, N S Y, times by our slip percentage, to get our slip speed equals. So that equals 1500 times by 0.04 equals, pressure of 60. Yep, 60 RPM. And then last, I want to know our rotor speed. So NR equals NS minus slip speed. And so NR equals our NS is our 1500 minus our 60. NR equals 1440 RPM.